Quick, another one of my very organic one-take videos. If you've got time for a cup of tea and a biscuit, by all means go and get them. What we're going to talk about is effectively failure and how to manage and mitigate failure, because it's something that happens in everyday life and you have to be aware of it. In production, in live stuff, failure is a thing that we consider, and then we try to kind of work our way around and give an envelope of safety that means we can get our task achieved. So I'll put some pictures up here. I was shown some fired ammunition, and it looked pretty horrific. There was a lot of burnt carbon on the outside. The cases were kind of warped. The primer had been damaged, or the primer had started to flow and almost weld itself back to the firing pin. And when I say these things, you may go, what is he talking about now? Well, there's a lot of misconceptions about what bullets are. Bullets are actually a number of components. You have the projectile, which sits at the very tip. Most people refer to that as the bullet, the projectile. Then you have the case, an elongated brass tube usually, of varying sizes, into which you put the powder, you measure the powder, the accelerant, and at the very end of that case you have a little recessed pocket into which an actuator cap, a primer, is seated, which the firearm strikes. It ignites the primer ignites the powder, it builds up pressure, and the bullet gets out the barrel, and the rest is history, wherever that lands. So why would you manufacture your own ammunition? Well, in some competitions you can get an advantage. It's not a cost-saving exercise, but it does give you an advantage over a period of time. You can buy manufactured ammunition, which is very good, but these are produced at 100,000 plus rounds per day by some of the big factories, and there is a degree of inconsistency, because as you can imagine, it's a process. These things run through at a considerable rate of knots, whereas you can actually manufacture, you can select the primer for certain properties, you can select the case for certain volumetric properties or strength properties, you can take the bullet, the projectile, and weigh them so they're all absolutely identical in weight, or as near as identical, and then you can very carefully measure the powder into the case and assemble the whole thing, and it can be a more consistent product. So why is failure this big issue? Well, the reality is really simple. If you imagine you're shooting a rifle like this, and you've taken your manufactured bullet or your home loaded bullet, your competition loaded bullet, you've put it into the thing, it is an explosion that is happening to this area or near your body. Now, in my old school way of thinking, any explosion that you can see, it means you're pretty much too close. And it is within that box of all your vital stuff that you have to keep safe. Therefore, what you're doing is not just mission critical and can give you an advantage, it is actually life critical to you or anyone near you. Predominantly, if you're right-handed, the bolt comes out, the rifle actuates and operates with a right-facing profile, so anyone to your right has a degree of shared risk, and shooters kind of accept this, and it's good. But as you'll see from the pictures, these cases can look horrific, and if you're at that cusp, that point of failure, you're kind of really reducing your safety margin, and this is why you need to be very, very conscious of what you're doing. You now have to attend a safety loading course, to understand what it is that is happening inside there. But there's also greater mechanical awareness, because you have to understand what your firearm is made of, how old it is, what its component parts are rated to, and you're managing all of those elements to have a safe delivery safe curve of pressure, safe trajectory of the bullet, a safe experience while shooting it. And we can go into that in greater detail, but realistically speaking, I was shown this, and my summary of what went wrong is pretty simple. The last 10, 14 days we've had extreme temperatures. Everything has been hot. We've had daylight temperatures of mid-30s. So it's hot outside. The firearm's made of metal. It is affected by external temperatures. The manufactured ammunition, or the component elements, generate heat, which affects the next round you fire. And as you progress through your shots, everything is getting hotter, which increases the pressure, which increases the risk of failure. So, that's something to bear in mind. And on a light-hearted note, we also have our favourite. It's just come back from a job, and somewhere along the line, this has been tagged up. It's managed to get itself broken. So we'll just do a quick, nothing in the magwell, nothing in the chamber. And somewhere along the line, the clever bit, the gas-filled magazine, this being an airsoft that we use for film and TV, now no longer fits into the magwell. So my presumption is, and you can kind of see it, this was used on a set where it had some quite significant rough housing, and it's been bashed around, so we have to take this apart and refit those component parts. So that will be our next video. Also, obviously, YouTube and Facebook now seem to absolutely hate the video and content that we put out, for which I make no apologies, but they don't like us to use the words. So we have this is a very good example, and it's everyone's favourite, of an airsoft for use in film and TV in our rental stock, and it's currently set to safe. It can do single or multiple effects, because I'm not allowed to use that word. And it's a shame that we've got bashed up, but we just have to take it apart and figure out what went wrong with it. So that'll be our next video. I hope you've managed to have your 5-10 minute break, and we'll catch you next time. Thanks very much. Take care.